Hi everyone. So today we are going to solve this very famous problem on Leetcode, that is two sum, and it's an easy one. So first we will try to understand the problem and then we will try to solve it, and we will try to optimize it if there exists any optimization for this particular problem. So let me just read the problem statement first so that we can understand the problem better. So we have given an array of integer nums and an integer target, and we need to return indices of the two numbers such that they add up to target. Now let's understand it with these examples. If the array is 2, 7, 11, 15 and the target is 9, so we need to return the indices of those two numbers such that if we add those two numbers, that should become 9. So if you observe here, if we add 2 and 7, that will become 9, right? So we need to return the index of 2, that is 0, and we need to return the index of 7, that is 1. So this will be our output. So this will be an array or vector, right? Now the second example is if the array is 3, 2 and 4 and the target is 6. If we observe here, if we add 2 and 4, that will become 6, right? So we need to return the index of 2 and the index of 4. So index of 2 is 1 and index of 4 is 2. Okay, now the last example is if the target is 6 and if we add 3 and 3, that will become 6, right? So we need to return the index of this first 3, that is 0, and the second 3, that is 1. Now, I hope you have got the idea now. Apart from these problem statements, we have few points, right, which we need to consider. So the first point is you may assume that each input would have exactly one solution. Now, what does it mean? So for target 9, there will exist only one solution and you can clearly see it here, right? So for target 9, there is only one solution, that is 2 and 7. So in what case there might exist more than one solution? Let's suppose for target 9, uh, there are elements such that 1 and 8. So if we add 1 and 8, that will become 9, and we have 2 and 7. So that will also become 9. So there will exist two solutions for target 9. So that is not going to happen. So there will be only exactly one solution for any particular target, right? Now, the second point is you may not use this same element twice. Now, what is it? What does it mean? If the target is 6, you cannot consider element 3 twice, right? So you may not consider the same element twice. If you add 3 and 3 two times, that will become 6. But this is not valid, right? So you cannot consider the same element twice, right? So these were the 2 points. And the last point is you can return the answer in any order. So you can return 0 or 1 and or 1 and 0. So both are fine, right? So 1 and 2 or 2 or 1, 2 or 1, both are fine. Now, I hope you have got the idea now. So first, we will try to solve this problem with the naive approach, or we can say the brute force approach. And later on, we will try to optimize it, right? So in the naive approach, what we can do is, let me just remove it. Okay, in the naive approach, what we can do, we can try the sum of all the numbers, right? So with all the numbers, what I mean, I'll take one. I'll try to add 1 and 7. Is it equal to 18? No. I'll try to add 1 and 11. Is it equal to 18? No. I'll try to add 1 and 15. Is it equal to 18? No. Let me just write down here. 1 plus 7. Is it equal to 18? No. Is it 8? Right. I'll try to add 1 and 11. Is it equal to 18? No. It is 12. I'll try to add 1 plus 15. Is it equal to 18? No. It is 16. Right. So we did not find 18. Right. So in that case, we will do. Now I'll take this 7. Right. Now I'll try to add 7 plus 11. So current element 7. Now I'll add the 7 with the remaining elements, right? 11 and 15. So to the right of this current element. 7 plus 11, is it 18? Yes. So the sum of 7 and 11 it is 18. So we need to return the index of 7, that is 1, and the index of 11, that is 2. So our output will be 1 and 2, or 2 or 1. You can return in any order. So first we will try to code this solution. First, I'll start the loop from 0. I'll go till the end of the array, or you can say the vector. So nums dot size I plus plus, and I'll start the second loop, which will go to the right of the current element to the end of the array. I'll start from the I plus 1, right? And it will go to the end of the array. Nums dot size. I'll just increment the j. If I found nums I, right, plus nums of j is equal to 18, right? We or whatever the target is. If that is the case, we will just return the vector with those two indices. So first index will be 0, the second index will be j, right? And if we do not find those two numbers, we will just need to return the empty one. Now just try to run this code and okay, it is accepted. Now think about the solution. So what is the time complexity of solution? It is clearly O of n square, right? O of n square, right? Right? It's a quadratic solution. So this is not a good solution. Now we will try to think about the optimized one. Now in the optimized solution, what we can consider, we'll take a use of map, right? Or we can consider it as hashing. In hashing, in this solution, what we will do, I'll start the loop from here. I'll check whether 18 minus 1 it is present in the hash or not. Right? I'll write hash. This is my hash, right? I'll check whether 18 minus 1 is present in the hash or not, right? It is not present, so I'll just store 1 and 0. So 1 is the element and 0 is the index, right? Now I'll just move to the next element. Now I'll check 18 minus 7 is present in the hash or not. So it is not present. So what I'll do, I'll just store 7 and 1. So 7 is the element and 1 is the index. Now I'll just move to the next element and I'll check whether 18 minus 11 is present in the hash or not. So 18 minus 11 will be 7. Yes, this is present. So now we have got those two indices. So from here, from this current element, I'll get the first index, and from this hash map, we will get the second element. Now just try to solve this with this solution. I'll just take an unordered map here, and this will store the number, and this will store the index. I'll just take hash. I'll start the loop from the very first index. I'll start the loop, and it will go to the nums dot size, right? I plus plus. Now I'll just uh, I'll just declare a variable for like complement. It will check target minus the current element. What will be current element? Nums dot I. Then I'll check whether uh, what hash dot find. So there is a function to find any element in the hash. Find complement, right? And this is how we do it. Hash dot end. Now, if that is the case, then we just need to simply return the vector. So what will be the now I'll just do it later. Now, if that is not the case, so we did not find any entry in the hash map for that particular complement. In that case, well, what we will do, we will just store that element and index in the hash. So I'll just so that will be nums I and the index, right? So this will be the element and this will be the index. Now from here I'll just get the first index, second index will be I, and the first index will be complement, right? It will be hash complement. Right. Now just try to run it and check whether it is running or not. Okay, we have got some problem here. Unorder. Okay, it's spelling mistake. and we have missed the semicolon there. Yeah, there's one extra. Yeah, if we do not find those two numbers, we just simply need to return the empty vector. This will do. Yep. Now this section. Thank you. I hope you understood. Thank you.